processing level, because all the ADV product, we have a library inside the software. So it selects automatically based on what criteria we have given it. And then setting and coordination of protection devices. Based on that, we will get the result. Based on the result, you will get the set point. The set point. Based on the full load current, you will get the set point based on the breaker setting range available. Set point on the short circuit and then full load current. And coordination of the protection devices. Coordination, the coordination level we will get it, whether we are achieving coordination or not. The first thing is, what is, I think short circuit, we know what is the short circuit current. When the short circuit happens, there will be a high current in the network. So what is that high current value? We are going to calculate it. Line current, voltage, strokes, everything is here. What is coordination? Coordination of protection. What is coordination? I'm going to write. What is coordination? Any input?
Sizing of the coordinating devices.
Okay.
Main power device.
Okay. What is the concept of coordination?
Size the breaker so that it can withstand the short circuit current. Maximum rate short circuit.
Even if we select the breaker based on the short circuit current and the load current, definitely it will withstand in the network. Definitely it will withstand network. Then why there is a word of coordination?
Upstream and downstream breakers.
Okay. Based on?
What levels?
Okay. See, basically the coordination in the sense, suppose we have a breaker and upstream, then we call this is a downstream breaker. Okay, this is upstream and then this is the downstream. So coordination in the sense there are two items involved. Okay, there is a coordination between this company and that company. So when there is a coordination in the sense, we are calling as a discrimination. The coordination, discrimination, all are same, but it has been used in a different manufacturer in a different places. Different terminology we can say, but everything is same. Coordination or discrimination or selectivity. Selectivity of the breaker. Now, if there is a fault here, if there is a fault here, assume that this is the main switchboard. Main switchboard. Okay. Main switchboard in the sense we have a main breakers here. Maybe a number of breakers or more here. When there is a fault in the switchboard, which has to trip?
The first trip.
This has to trip. Obviously, if this breaker trips, what will happen? We will lose the supply for complete network. So what coordination is saying, when you have a two breaker, when there is a fault at the point of fault, the immediate upstream only should trip. You should not trip the upstream breaker. So you will have to select the breaker in such a way that to ensure this coordination. To ensure this coordination. Only this breaker should trip and this breaker should not trip. How to ensure this? When you ensure this, and we can say that the discrimination is achieved in the network. Discrimination in the sense, we have a total discrimination or partial discrimination. Definitely, in all the places, we may not achieve total discrimination in all the levels. So that is why total discrimination or partial discrimination. What is the total discrimination in the sense? I think we have told now, when there is a fault, immediate upstream trips and this doesn't trip. This is called total discrimination. When there is a partial discrimination, there is a possibility to trip this breaker, but based on the short circuit level. Irrespective of any short circuit level, either 25 kA or 35 kA or 50 kA or 65 kA, whatever the fault level, this two breaker ensures the discrimination, irrespective of fault level. But when you come to partial discrimination, the partial in the sense, so there is a value. Maybe, I think I'll show you the discrimination table. I think you might have seen the APB discrimination table. In the table, you might find the wording. Suppose here NS breaker or mini breaker will be there, and here you will have mini breaker, and here you will have tables. And some places you may see the total discrimination, and some places you may see the value 5. So this is called a partial discrimination. And this breaker, suppose here I have a breaker of 100 ampere, and the upstream breaker is 400 ampere. Okay. So now we are coordinating between, this is called upstream breaker, and this is a downstream breaker. And when you come over here, and this midpoint is a T. That means when you install this breaker as upstream, this breaker is downstream, you will get a total coordination. That is the manufacturer declaration. We don't need to calculate anything. You can say to the customer directly, we are getting coordination between this breaker and this breaker. And some places you may find the values 5 kA, 10 kA, 20 kA. This is called partial discrimination, which means that up to this level, suppose this fault level, here is the fault level is around 20 kA. Okay? 20 kA. That means calculated fault level in the network, not the breaker fault level, breaking capacity, no. The calculated fault level is 20 kA. Okay? And the table is here. For example, here is 25. Here it's a 5. For example, if we receive this 5 kA in the sense, up to 5 kA, you will get the discrimination. More than 5 kA, discrimination is not guaranteed. Which means that up to 5 kA, this breaker only will trip. More than 5 kA, this only may trip, or both may trip. It's not guaranteed. For example, suppose 20 kA, we got the value of 25 kA. So this is, the fault level is lesser than this value. So definitely you are achieving discrimination. So understand that either you have a discrimination T value or the fault level is lesser than this value, you can say that 100% discriminated. If it is more than that value, it is not discriminated. You can say partial discrimination. This is the basic. Any doubts on this? Then we can go to the presentation, the software presentation. Fine, I hope clear. Now, this, just to understand the software, we made a presentation. Definitely, we will open the software in the laptop and I will make one sample based on this. Then it will be more clear. Just to get an idea, this presentation. When you install the software, launch the software through software desktop, then initially you will get this table. That means all the tables, information you will get it when you open the software. Of course, to get output, we need to give some input. So the basic input, the network input, like system voltage, what's the earthing system, okay? So what is the transformer rating? What is the transformer impedance? And then breaker 3-pole or 4-pole. So there are, and cable sizes. Now we are going to see the example in a routine activities what we are going to do it. For the dimensioning of cables, which is not useful for us. Why? Because, for example, in this market, calculations are based on the IEC standard. Suppose, for example, it may calculate for 25 square mm. For 100 ampere circuit, it calculates 25 square mm. Of course, in a UAE regulation, and based on ambient, this, and calculations, everything, it goes up to the 35. Or depends the long distance voltage drop, it may go to the 50 square mm. So when you calculate the software without any input of cable size and breaker size, the result of cable size and then breaker size will not be suitable to this requirement, suitable to this market. So always we are going to calculate short circuit level based on our input to the system. That means we have a single line diagram, already we have the breaker data, already we have the cable data. So we are going to give the data and get the result of short circuit calculation, short circuit level. Okay, based on that, you can stop me anytime, any doubts. So now the basic data, we have a different options here. That means for LV distribution, suppose we may take the job from the SMDB level. Okay, not the complete project. If the calculation to be done from the partial level of the network, we can use this option. That means we have to give here the fault level. Maybe SMDB fault level 36 PA. From that level, you calculate and tell me, based on the DB level, MCC, whatever it is. So based that option, you can choose this option. But generally, we use this option for the project from the transformer level. From the transformer, we calculate it so that the calculation result will be accurate. So normally we choose this option. Of course, we have to give the transformer rating, and then this is important data of the transformer. Depends the impedance. So basically, short circuit level changes based on the impedance level. The resistance and reactance and impedance level. So that impedance level we need to put it here. Maybe you can choose generally the 6%, or if you want to be so accurate, we have to get the details from the contractor and feed that input. Of course, we need to give the general, the system level, what is the voltage level, and the network, whether it is 3-phase or 3-phase neutral, and everything, system, everything. Fine. So we are giving this input here, and then layout selection. It will ask to select the layout. This is nothing, just to have a printout. The printout size A3. Maybe we can do it in A3, or in suppose in a contractor side, maybe they may have a A0 size, A1 size printer. Right? They can feed all the input in one sheet. But normally, nowadays we may have only A3 printouts. So we can choose the layout or selection A3. Now this is the main working area for the software. Working area for the software. Here we have symbols, and here we have menus here. Of course, if you pull down the menu, you will get the sub-menus. And same thing available in the toolbar also. Normally, we can work with the toolbox. And this is the area highlighted, and here you can see the option. This is for MV, medium voltage side, in which we are not going to use this software for medium voltage. And this symbol for the low voltage icon. When you select this low voltage, you will get the symbols, low voltage related symbols. And this is for, you can see the calculator symbol. Once we finish all the inputs, like a single line diagram, all the cable size, breaker, type, everything is selected, then ready for the calculation. When you press this, it calculates and you will get the result. And this is to get the time current characteristics for breakers. You will get time current characteristics for the breakers. Maybe that characteristics are required to justify, what is the setting range, what is the setting level. Maybe we can justify the coordination also in a different method. Sometimes in a coordination table, you may not be able to get the coordination. But by setting adjustable, by adjusting the setting ranges, we can draw the curves. We can draw the curves of upstream and downstream, and we can show to the customers if it is not clashing together. So for that purpose, we can use the curves, and then accelerators we will not use it. Accelerator is to make the control circuits, like the push button symbols, everything will be there. I think these are all additional options compared to the earlier version, Docwing. And document, I think this are all will be available. This are all was available in menu, I think before in the document. Now it is in easy way, it is given on the slides. And then we can use this symbol for the documentation, like a printing and selection of outputs. Fine. This is the lower dish icon. And now once you open that, then we have to start making the single line diagram by using the symbols. We will see one by one and open the faster. Once we finish the single line diagrams, then it goes to the first finish the the network, breaker, cable, and then everything. Then start giving the input. Breaker, transformer data. Transformer data already we given it. So still we can open and see that whether data available or not. And then cable data and the breaker data. Breaker data, I think since it is ABB channel partner, you are familiar with breaker sizes and types everything. So we can go directly here to select. If you select this button, it goes to the library, and from the library you can choose ACD, NCCD, NCD, switch disconnector, all the ranges are there. So from that you can pick up. So automatically it comes over here. And there is one symbol here. This is important nodes to all. This symbol. This symbol is open now. There is no lock. When we give any input, that is a customization input, we are giving input to the system. We are giving input to the system. See, the breaker is selected already. The software has the ability to select the breaker based on the load current. If you don't lock it, we might have selected 3200 ampere, but the actual load is only 1000 kilowatt. Maybe 2000 ampere AC is sufficient. So the software will change automatically to 2000 ampere. Not only this, breaker, everything will change. So we have to do exercise again. So wherever in the cables or in the breaker size, once we give the input, lock it so that the system will not change the parameters. Feeder properties. Feeder property in the sense, supposing the one feeder contains the breaker, cables, loads, everything. So we will get in the one table. Whenever we want to edit it, we can choose LED cable, circuit breaker, and we can edit it. So panel is mainly here loads. So now we have given the input transformer, and then a breaker, and then cable, finally to the load. So the load details to be given here. There are different options, utilization factor. That means maybe the load will be 100 kilowatt. Maybe we are not used it for 100%, 86% or 85% or 90%. Maybe sometimes utilization factor. And then the power to be selected here. And then we can view the system for the calculation. Now, like a lock symbol, this is also one of the important nodes, renumbering. Renumbering in the sense, suppose the dock software alerts the equipment reference symbol automatically. The reference symbol automatically in a vertical and horizontal way. Suppose this is QF1. Then it alerts automatically QF2. Then QF3. Like this. In the cables, everything. For example, after drawing this, you may say that, oh, this is on the other MPP, deleted. You have deleted. Okay? So what will happen? In the other side, you will have a QF4. Okay? Okay, you finished it around 10 numbers. Then there is a gap here. Okay, we'll insert one more feeder here. Maybe this will be QF11. So it alerts automatically. But if you see that it's not in a sequence. Suppose if you don't insert it, you will be having a missing numbers. QF3 will not be there. When you see that where is the QF3, then you have to search it, find out and what is, then no idea. So after finishing the single line diagram, editing whatever it is, editing everything, before going for a calculation, just do renumbering so that it will alert the number in a sequence, so that in when we are doing the output or presentation, it will be very clear. That is one important thing. Other thing, edit everything we'll see in the software. So once you finish it, then we can go for the calculation. Once you do the calculation, we will get the result here. The short circuit level. This IK in the sense it's a short circuit, and this is the IEC terminology. L, that means 3-phase fault level. 3-phase fault level, 36.8 kA. Then if you want a LG, LL this is 2-phase fault, 3-phase fault, phase to phase or phase to neutral, phase to whatever, we can pick it. There are output options that we can choose. Or we can edit the label also, because IKLL. Before this, who are all known about this? IKLL, LLL. No. If you submit to the contractor, they will see what is IKLL. Maybe you will have to travel from you to Abu Dhabi to explain this. Right? So it is difficult. So we can edit the label while giving a output. We can edit like short circuit level. The label can be edited, but the value cannot be changed. Value will not be able to change. Only the label can be changed according to the easy terminology, which is known to everyone. Like that we can change it. Then this is the curve which I was telling. Maybe you can use the symbol. Say suppose we will get all the equipments, whatever we drawn in the SLE, we will get all the items here. Cable, breakers, everything will get. So we can compare it. What is the characteristics for the cable? What is the characteristics for the breaker? Now consultant may say how this cable is protected. Maybe the cable, the cable will be here, and then breaker will be here. So when there is a fault, first thing the breaker will respond. So the cable is protected. So like that we can give a comparison in the characteristics wise, not in the documentation. So for that we can use this. And also here you will have a verification of protection. So first we calculate the short circuit level, and then but of course it should say that whether the protection is achieved or not, the cable. The protection in the sense you have 3 types of protections. We can say that overload, which is exceeds the normal current, which will take time to trip the breaker. And then short circuit protection, and then entity means indirect edge protection, non-direct edge, that means edge fault. That is IEC terminology, non-direct edge, that is edge fault. So it ensures the 3 protection based on this breaker and then this cable. See? Upstream and downstream. These 3 protections are okay. But when you don't achieve the protections, you will see a fail. Then we will have to see that. But it's not our duty, because the contractor has selected the cable size and the breaker, everything. Breaker size, everything, they have selected it. Cable size, they have selected it. But main thing is to calculate the short circuit level. To justify that, the breaker provided is sufficient to the network. Right? But this can be, as additional information, this can be, suppose if we have good relations, this can be informed to the contractor. So this is not protected, take care. Maybe you will have to increase the cable size, and you will have to increase the breaker size. This additional information, when problem comes, you can retrieve it. And then documentation. How the documentation? The earlier version also you will not find this much facilities. You have to select the reports. You can select different reports. Only the cable report separately, devices, and then circuit breaker, and then calculation. Only the fault level calculation and report of protection. This is what you are seeing now. And what are the protections achieved. And it can be printed in the PDF file also. It's not I'll show you the software. to the software now. I will just it's saying the give attention to warnings. This is very intelligent software because it gives error. Whenever we do error, it will say you are on error, and there is a warning message will come. And if you bypass warning message, everything will be error. So give attention to always warning instructions. Just it will give a two type of information. One is error, and then another is a warning. The difference between two, because sometimes you may say that for example, I'll show it in the software also, how warning and error. Suppose network is here, you inserted the parameter, but you are not inserted properly here. The network started from here. This is error actually. So without any connection, it cannot calculate. So there is an error in the network. It will not calculate. It will come out from the calculation. But some of the things, it's a warning message. Maybe we can say, okay, it proceeds with the calculation. For example, I'll show you the fault curve also. There is a transformer, and then we will have a cable, breaker, and it's connected to the, okay. From the transformer cable and breaker, this is LV channel, LVP. Now the cable is protected or not? The cable is protected or not?
Transformer cable.
From the transformer to breaker.
Yeah, this cable, it's protected or not? Protected.
Transformer.
Yes or no? Objective. No. Why? Because the breaker is in the downstream. Okay. If there is a fault here, there is no device to detect the fault. Only the cable will see the fault. But if the fault here, definitely there is a breaker. So definitely it will detect the fault. It will open the breaker. But this can be changed? No way, because the regulation is like that. It comes only the cable. The regulation, we cannot change anything. The system will say the cable is not protected. Cable is not protected. It is a warning message. But for the software, it is not a problem because the network, everything is correct. It proceeds. Okay. Maybe the breaker, the current capacity is very low, insufficient current capacity. Okay, the breaker. Maybe we selected 100 kilowatt. We know that we are not going to use 100 kilowatt. We are going to use only 50 kilowatt. Maybe based on 50 kilowatt, you might have designed it. So it will say it is insufficient. Okay, I know this. Okay, proceed. This is a warning message. So with a warning message, you can proceed with the calculation, but with the error, you will not be able to proceed it. Fine. So when we open the software, now you will get the same message. That means details in the table. Now we'll have to feed the input. Now I am choosing here a transformer. One transformer. What kV we can put? 1500. 1500. See, I'll tell you, here there is no predefined value as 1500. 1250, 1600. But however, you can type it. We can type it 1500 kVA. And then percentage impedance. I am selecting 6%. That is the normal here, 5.678. And then system is 400. And then 3-phase neutral. LL means 3-phase neutral network. EMS system 50 Hz. Everything is fine. And then network for the breaker. Normally 3-4. Because even though 3-phase 4-way system, outgoing breakers, everything will be in a 3-4 system. Okay. So this doesn't change any value in the circuit level. Just for the information. When you have window, you will have the information. Single port. And MCB for, there are two standards for MCB. Anyway, that we are going to feed the input. We are not going to select from the load. So let it be 947. This is what I was telling you. You can suppose you can show to the consultant also. See, the method of calculation is 909. There are options, but for the low voltage, this is the standard. And then cable dimensioning, there are another insulation method also, but everyone follows IEC electrical insulation method of 364. So ambient temperature we can change it here based on that the duration of cable and the breakers and everything will change. So 30, 40, whatever we can change. This you don't need to change because this is based on the protection area. And then choose automatically, we don't want to choose automatically because we are going to give the data. Okay, fine. Now I am saying okay. Second, it lost the layout. A3 layout is here already. So I will say okay. So now the symbol starts with a transformer. Symbol starts with a transformer. Now we are going to draw the one simple network. One simple network. Because it's going to be repeat actually. Breaker, cable, whatever SMD will available. Just I will draw one typical. Before that, I will explain here. These are all the symbols we are going to use it now. These are symbols and this down. And first you can see the source symbol. Source means generator, transformer, all the symbols. Here the UPS anywhere, generator, transformer, and then 320 transformer. Anyway, this is mostly useful. And then you have a connection device. That means cables. Source and then cables. Here you have a busway. That means bus switches. And this is bus bar. Again cable and then bus bar. You can see the sequence on the bus bar. And this multimeter. This I will explain you separately. Multimeter. What is multimeter? This is not the network equipment like a breaker, cable. It's not. It's like auxiliary equipment to measure the parameters. And this is the breakers. Here all are breaker in a different option with RCB, without RCB, overload, short circuit, and without overload. There are different options. And then switch disconnectors. And this is the load area, generic load. That means some kind of load. 200 kilowatt, 300 kilowatt. Maybe you have computer, this, that, lamps, everything. But we are not going to define it separately. 200 kilowatt, 100 kilowatt. And then if you want to have particularly, you can have a motor load also. And these are the connection devices. These are also not the equipment. It's not an equipment. It's a connection device to have a comfortable drawing in the while you are drawing the single line diagram. How? For example, here there is an end node. Here we are going to start with a cable. But if you draw the cable like this in a horizontal and then break a horizontal, it will not be good representation. Consultant will see, my SLD cable is like this only. Okay, why you put it in horizontal wise? It's not easily identified. For that also you will have to give more explanation. Better to avoid. So now this is the connection device between one place to other place. Suppose if you have a breaker here and then you can connect the device. Now for example, I am taking this connection device from here. See, automatically like AutoCAD. If you're familiar with AutoCAD, it's called the nodes. Everywhere there is a nodes. So the object also will end up with the one node. So it will, when you go nearby that, automatically it will go on the sit with that node. So in the node, again you are drawing, I'm making to the center now. From the center again, coming here. Okay, fine. This is it will continue again. Then press escape to discontinue. Now what is next?
Transformer.
How? Cable. This is only a connection device, not a cable actually. So just to make a representation, we made it. So now for the cable, you can see here another beauty is here. When you go nearby the tool, automatically it will represent the symbol. The symbol is for what? So cable. So click cable and then insert escape. After cable it will be breaker. I am selecting breaker with overload and sensitive protection. Click, insert, escape. After this, bus bar. Okay, bus bar if you start here, only one end will be there. So start from here to there. So after that, just I will make one outgoing breaker, outgoing feeder, breaker. Then it log username. Just take some time. User in the sense the feeder name. You can give the feeder name. I am giving like just SMDB. SMDB1. Or we can just leave it, then you can edit it up. Let's click. Yes, cable. So like this we can draw, from the cables again the incomer, breaker, then like SLD we can draw it. But just I will give one load here. This will give all the typical information. That's all. One load. Okay. Finished now. So SL is finished. So typical. Because these are the input we are going maybe in a multiple way, but this is the basic input. Okay, transformer we have given already. Just go there, double click and see 1506% everything is there. So fine. And then cable. And the cable maybe I can write incomer. Length of the cable. How much length we can use? 30 meters. Just maybe 15 meters. 15 meters. Of course, not even single core. Because always incomer will be a single core cable. XLPE. Of course, copper. Installation method. It means whether by ladder or by trench or by overhead. So like this we can have a different installation method. There is a ISS 10 number here, the installation number. If you know well, you can tell it. Otherwise,